So this is where we ended the last video, doing stoichiometry and these problems. And let's just continue doing problems. So I think sometimes this could be a little tricky and overwhelming when you look at something like this, and converting from grams to grams, it's easy to get lost. So I think the more problems we do together and that you do as you watch these videos and in the homework, you're going to get better and better at it. So let's just do 3 more problems. Okay. So how many moles of oxygen are required to burn 3.50 grams of liquid heptanes? Okay. So first of all, what we need to do is write down and balance the chemical equation and then go from there. So since you saw the other 2 examples in the previous video, why don't you try to do all 3 of these examples we're going to show in this video by yourself? So write down the balanced chemical equation and then convert from grams of liquid heptanes to grams of oxygen. Okay, so the first thing is to write down the balanced chemical equation. This is what I'll do here. Hopefully you got this. I'm pretty sure that is balanced. And now what we're going to do, again, we're going to write down what is given, okay? Okay, and I want grams of O2. So then I'm going to write down my path here, just switching colors. Again, I'm going a little bit faster here because I just want to catch up to you guys. You already did the problem. 3.05, or at least I hope you did. You didn't just stare at me, waiting for me to do it. 16 mole O2, gram O2. Okay, so that's my path, going from grams of heptane to moles of heptane to moles of oxygen to grams of oxygen, okay? So let's do it. So the molar mass for, well, let me do it this way. Hold on, getting ahead of myself here. So I have 3.50 grams C7H16 times, for every 1 mole of C7H16, there's a certain number of grams, and that comes from the molar mass. So if you do that here, we have 7 of them. Right off the periodic table. This is the molar mass. I got 123 grams per mole. Okay, so 100.23. Okay. So, all right, so continuing on then. So now notice again, grams of heptane cancel with grams of heptane. So now I'm at moles of heptane. So to do the next conversion, we use the coefficients. Okay, so for every 1 mole of heptane, there are 11 moles of oxygen. Okay, and again, these units cancel out. That's a key that needs to happen. Okay, and then finally, for every 1 mole of oxygen, we've already calculated this guy before, 32.00 grams of oxygen. That's just its molar mass. Okay, so, and once again, I'll just cancel all the units. Moles of oxygen cancel with moles of oxygen, and the unit we're left with is grams of oxygen. And when you put all of that into your calculator, you should get 12.3 grams of oxygen. Okay, so hopefully you got that answer. All right, and go through, and if you didn't, and try to figure out where you went wrong and any steps that you may have missed there. Maybe it was in balancing the equation. Maybe you didn't balance the equation right. If you don't, you're going to get these coefficients mixed up. Okay, so let's see here. I'm just checking real quick. Okay, so let's keep going. Let's do another one. Again, pause the video, read through this problem on your own and try to do it. Okay. So it's the same equation, first of all. So let me just write that down. 16 plus 11O2 gives me 7CO2 plus 8H2O. Okay. Okay. So again, read through this problem, try to do it on your own, and then we'll do it faster together. Okay. So the path is pretty much the same, except now we want grams of CO2. So again, I'm given 66.0 grams C7H16, and I want grams CO2. My path, okay, is going to be 66.06 grams C7H16 of the heptane to moles of the heptane to moles of CO2 to grams of CO2. All right, so how do we do this? Well, same idea as before. We're going to convert grams to moles first using the molar mass, okay? So the pattern, I guess that's why I'm doing so many example problems here, is that the pattern stays the same pretty much when you're doing these problems. So you could just essentially memorize the pattern that I'm doing here and apply it to the problems that you're going to see. It'll help you a lot, I think. So I'm just going to write all this out, okay? Okay, going faster again, because we've seen, what, 4 examples now of this? Okay, this is from the molar ratio. 7 moles of CO2 for every 1 mole of the heptane. Okay, and then for every 1 mole of CO2, we can find its molar mass, which I think we calculated before in another problem, 44.01 grams of CO2. That's what I have written down here. Okay, now check your units again. Grams of heptane cancels with grams of heptane. Moles of heptane cancels with moles of heptane. Moles of CO2 cancels with moles of CO2. And I'm left with grams of CO2 as my unit, which is what I want, right? So putting all that in the calculator, I get 203 grams of CO2. Okay, let me just double check that, and hopefully you're double checking your work too when you calculate something, because sometimes you could just put something in your calculator weird. Yep, so that's the answer. Okay, let's do one more example problem. Okay, so it gives us this reaction here. It says, according to the reaction shown here, where silver nitrate combines with copper to give me copper 2 nitrate and silver, how many grams of copper 2 nitrate will be formed upon the complete reaction of 26.8 grams of copper with excess silver nitrate? Okay, so again, pause the video, try to do this one on your own, and then we'll go through it together. Okay, so one of the things, again, is to write down what's wanted and what's given, because this part here with excess silver nitrate, right, is useless, okay? It doesn't actually help us at all with this problem, which is why, again, we want to write down what's wanted and what's given. So we're given, I should say, right, given 26.8 grams of copper, right? And I want, okay, grams of copper 2 nitrate. So again, the excess silver nitrate part is not really very helpful to us right here. Okay, so again, I'm going to just write down the path. Okay, so the path, 26.8 grams of copper, right, to moles of copper, to moles of copper 2 nitrate, to, just let me move my screen here a little bit, grams of copper to nitrate. Okay, so this is the general flow of what we're going to do here. Okay, so again, let's just go through and do the problem. Okay, so 26.8 grams of copper times, we can get its mass here off the periodic table. For every 1 mole of copper, I have written down that there's 63.55 grams of copper. Okay, and then according to our equation here, for every 1 mole of copper, there's 1 mole of copper to nitrate. Okay, so now finally, if I want to convert to grams of copper to nitrate, I need its molar mass that I could calculate. Okay, so we finish writing that out. So for its molar mass, so copper is 63.55. Nitrogen, I have 2 nitrogen, and I think it's about 14 off the periodic table. And then for oxygen, I have 6 of those, and that's 16 off the periodic table. Oh, hold on. 1 second, it's going to kick me out. Okay, hold on. I hit the wrong button. Okay, I got too far down to the bottom there with the annotations, and it kicked me out of the PowerPoint. Okay, so you add this up. The molar mass for this I get is 187.56 grams per mole. Okay, so 187.56 grams copper nitrate. Okay, so you put all that into your calculator, and what you should get is 79.1 grams of copper to nitrate. Okay, that's my answer. All right, so again, this is how we do stoichiometry and look at these different chemical equations. All right, so plenty of examples given in these last few videos of doing these sorts of problems. We're going to do plenty more examples when we talk about percent yields and things like that in next week's videos on this chapter. So go through, review these problems that we did here, and the homework will be posted actually next week for this chapter, because this week there's an exam. So good luck on that exam. If I don't hear from you, or maybe you're watching this after the exam, I don't know. And I'll see you next week.